All right, now we're going to do our checkpoint 4. And I'm going to read it, go ahead and pause, work it out, and come back. It says, from the time a small airplane is 100 feet high and 1,600 ground feet from its landing runway, the plane descends in a straight line to the runway. Determine the angle of descent in degrees of the plane. Round your answer to 2 decimal places. Okay, go ahead and pause, work it out, and then come back. Okay, so let's draw a picture. So we've got, let's say this is our runway, right? And so our plane is right there. And it says at the time that it starts its descent, it's 100 feet high and 1,600 feet from the runway. Okay, so that means that this height is 100 and this length is 1,600. And it's in feet. Okay. And so it's descending in a straight line. And I want to determine the angle of descent. So the angle of descent, so here's the way you do the angle of descent. Remember, the airplane is here. So it's along this horizontal. So the angle of descent is that. Okay? But remember from geometry, when you have 2 parallel lines and you have a transversal, alternating interior angles are congruent, which means this is going to be the same as that angle. And so now we're going to use tangent to find this angle. Okay, so tangent of theta, okay, let's call it theta prime, equals opposite over adjacent, so that's 100 over 1,600 feet, right? So 1/16. So it's the tangent of theta prime equals 1/16, okay? Which means if we take the inverse of both sides, right? Multiply both sides by the inverse, right? Arctan. Right? So we get theta prime is equal to arctangent of 1 over 16. And that will give you the answer. Now I don't have arctangent on my that I have available to me, but again, this should give it to you. Again, you want it in degrees. Make sure you're in degree mode, and then of course, theta is equal to theta prime, and you should get the correct answer. Let me know. Have a great day.